GMAT 41. You are welcome to our ordinary differential equation class. In this video, we now want to look at certain equations that are reducible to separable variable equation form of O.D.E. What does this equation look like? How do you reduce them to separable variable equations so as to integrate and obtain your result? On the board here, we have this short note as a guide. This equation is of the form, you can see, y prime, which is the same as dy dx, equal to a function of, you can see, ax plus by plus c. So this is the form in which the differential equation take. The constant coefficient b should not be 0, which means that this y term must be in that equation, alright? If b is 0, you notice that this by term will not be there, but it's not allowed. The y term must be there. Now if you look at this expression, you'll agree with me that this expression is an expression of degree 1 in x and y. That is that the power of x and y there are what? 1. Now how do we solve this problem? How do we reduce it to separable variable equation? But before I say that, I want to state clearly that this equation somehow looks like homogeneous equation form of first order ordinary differential equation. It looks like it, but they are not exactly the same. You will have to endure. When we get to homogeneous equation, we are going to see clearly the difference between this equation and how homogeneous equation looks like, okay? Fine. Now how do we reduce this to a separable variable equation? We use a transformation to do that. And that transformation is given by equation 1. That is u is equal to ax plus by plus c. You should know this transformation. So you have to memorize it. You use it to reduce this differential equation to separable variable. But do not forget, you are expected to differentiate this transformation with respect to x, and that's why we'll have this equation 2. So you're going to have du dx, look at it, equal to, if you differentiate ax with respect to x, you're going to get a. And then differentiate by with respect to x, b is a constant, so it remains there, and then differentiate this y with respect to x, you get dy dx. Differentiate this constant c, you get 0. What is the purpose of this transformation and the derivative of this transformation? It's quite simple. You're trying to do something to reduce this differential equation to a separable variable. So that's really what we are trying to do here. So we are trying to reduce this equation to a separable variable that will now contain u and what? X. So that you will now solve that separable variable equation which contains u and x, obtain your result. Now, after you've obtained your result, what are you expected to do to this u? Because of course, your final result should be in x and y. Being that the question given to you is in x and y. So at the end of obtaining your answer, all you need to do is to replace your u back with the value of u, which is ax plus by plus c. In the next video, we're going to take questions of this kind and then solve them to see how we use this transformation to solve this problem. We have this first question on the board here. We are to find the solution of the DE, the differential equation y prime, which is the same as dy over dx, equal to 4x plus y plus 1, everything raised to the power what? 2. Now if you look at this differential equation, it is of this form. Because this function is a function, alright, which is of degree 1 in x and y. Irrespective of this power, is that okay? So we're going to call this whole term u. And you know that to solve a problem like this, you reduce it to separable variable form using the transformation u equal to ax plus by plus c. Where in this case the ax plus by plus c is this term in bracket here. So we shall say let u be equal to 4x plus y plus 1. Call this equation 1. If we do that, you will agree with me that dy dx will be equal to, this whole term in bracket is u now, so I will put u and then square it. We call this equation 2. Recall that once you define a transformation, the next you have to differentiate that transformation with respect to x. Is that clear? So we are going to differentiate equation 1 with respect to x. If you differentiate equation 1 with respect to x, we are going to get du over dx du over dx equal to differentiate 4x with respect to x, you get 4. Differentiate y with respect to x, you get dy over dx. Derivative of this constant is 0, so it goes up. We'll call this equation 3. Now look at this equation 3. Do you notice that it is free of y now, the variable y? The only thing about y here is this differential coefficient dy, which must be replaced as well too, because we are trying to reduce this equation into a separable variable equation that will contain u and x. How do we now achieve that from here? Can you check equation 2 and notice that dy dx has a value which is what? U squared. So we can substitute equation 2 into equation 1. This will give us du over dx equal to 4, and then plus dy dx is equal to u squared. So you fix in u squared. Let's cross multiply this and see. Du will now give us 4 plus u squared times dx. Did you take note that this equation is separable variable equation? Why? This is a u term multiplying the parent, the differential coefficient dx. It's multiplying it. And you know you can remove this from here, this 4 plus u squared, you can remove it by separating the variable using division. Is that also? So this is the separable variable equation in u and x that we're trying to target. We now need to separate the variable and then integrate. To separate the variable, we need to remove this u term from this differential coefficient of x, because this is supposed to be controlled by this parent du. If this 4 plus u squared is to come to this du part, it's coming as denominator, so you have 1 over 4 plus u squared, then du equal to the x to be left, can now integrate. Integral of this term will give us 1 over square root of 4 tan inverse of square root of u squared divided by square root of 4. And that will be equal to integral dx will give you x plus c. Why did we get this as a result? This is standard integral value of tan inverse of x. But in this case, the variable is u, so it will be tan inverse of u. Please visit our YouTube channel and you'll see the standard of this type of integral, how it gives us this value. Please subscribe. So I want to upload certain basic concepts. You can get them, which of course will help you. Integral dx gave us x. It welcomed back the variable. Why? Because it is not the differential coefficient x that you integrated. Differential coefficients only tell us what we are integrating with respect to, as the case might be. So why is it that this now gave us x? You can also see these concepts by watching our videos in YouTube channel. So we move on. 1 over square root of 4 is going to give us 1 over 2 tan inverse square root of u squared. What is going to happen? You notice that this square root will cancel this square. Okay? Then u is left. This will be tan inverse of u. And you know that u is 4x plus y plus 1. So I will substitute 4x plus y plus 1 and then divide everything by square root of 4, which is 2, equal to x plus c. I may wish to clear the fraction using this 2. Please take note that this 2 here is inseparable from this term. All of them are terms in front of the tan inverse, okay? So this is what we are saying to use in clearing the fraction. So we're going to multiply the numerator through by this 2. If you do that, 2 times this term here, that 2 will cancel this 2. So that tan inverse will be left, tan inverse of 4x plus y plus 1 divided by 2. That will be equal to 2 times this x will give us 2x. 2 times this constant of integration will give us 2c, which is of course the same as what? C, the constant of integration. And this is the solution of that differential equation. We have this next question on the board. We are asked to solve the equation x plus y dy equal to 1 minus x minus y dy, dx rather. Now if you look at this question, you will notice that although x plus y is not of this form because it does not contain the constant c, but this part 1 minus x minus y is of this form because it is an expression of degree 1 in x and y, and it has the constant 1 there. So it looks like this. Therefore, we can reduce this equation to separable variable form using u equal to ax plus by plus c. But first, to do that, we rewrite it as dy over this dx will come as denominator here, that is dy over dx, so that we'll get our y prime. This dy over dx is the same as y prime, then x plus y will come over here as a denominator, 1 minus x minus y all over x plus y. We can now select the numerator to be equal to u. Is that okay? Since it is of this form. Alright, let u be equal to 1 minus x minus y. If I let u to be equal to 1 minus x minus y, I can replace for this numerator. I can replace that numerator with u. Is that also? But look at the denominator, we have x plus y. It still contains y. We need something that will help us replace this y there. So what do? We're going to look at this equation and see if there's any way we can rearrange this transformation to get x plus y in terms of u. Watch something here. If minus x crosses to the left hand side, it will become plus x. Minus y crosses, it will become plus y. Everything will be equal to 1. Then u will cross to the other side of the equation. You have minus u. Did you notice that x plus y now is equal to 1 minus u in terms of u? So we've arrived. We'll call this equation 1 and call this equation 2. Watch something. Our y prime, which is dy dx, will now be equal to, in place of the numerator, we'll put equation 1. And then in place of denominator, we'll put equation 2. Look at it. This will go as equation 1. We'll go for the numerator, and then this will be replaced for the denominator. That will give us, for 1 minus x minus y, we put u all over x plus y, which is 1 minus u. Remember, this is y prime, so it's the same as dy over dx. Alright, we've done the first important thing here. The next thing is to differentiate the what? Transformation. Remember, once you define any transformation, you have to differentiate it. Because the aim of all of this is to replace any y term and dy term there with the variable you are using for the transformation. Therefore, I will differentiate equation 1. Please, let's call this equation 3. Alright, with respect to x. And say if I'm differentiating equation 1, this with respect to x will give me du over dx. Equal to differentiate this one, you get 0. Differentiate minus x, you get minus 1. Differentiate minus y with respect to x, you get minus dy over dx. Therefore, du over dx will now be equal to, what do we do from here? We're going to replace this dy over dx with the value of dy dx. Remember that dy dx from equation 3 is u over 1 minus u. So this equation 3 will be substituted here. Is that okay? And if I do that, du over dx will now be equal to minus 1 minus, in place of this dy dx, I will fix in u over 1 minus u. We can simplify the right hand side further. See that du over dx will be equal to, we're going to use LCM and work out this, but before I do that, let me show you something very nice you can use. Is that okay? If you have something like 1 minus, let's say 2 over 3, that is to say adding or subtracting a whole from a fraction, or a fraction from a whole. The fastest thing to do when handling the LCM is use the denominator to multiply the whole number. 3 times 1 will give us 3. Then minus the numerator, everything divided by the denominator. Is that okay? Look at it. Denominator times whole, minus in this case, if it is plus, you put plus. The other numerator, then everything divided by the denominator. So we can do that here. 1 minus u is the denominator here. So it's going to be 1 minus u times minus 1. You know what that's going to be, is that not so? If you use this to multiply minus 1, these signs will change. So it's going to become minus 1 for this, because this times minus 1 will give us minus 1. Then minus u times minus 1, which will change to what? Plus u. So this minus 1 plus u is the value of 1 minus u times this minus 1. It's going to be minus this numerator now. So minus this numerator, everything divided by the denominator. So use this as a guide. Is that okay? Therefore, du over dx is now equal to this plus u and minus u will give us 0. So they cancel out. So we are left with minus 1 over 1 minus u. And this is our separable variable equation in terms of u and x. You can separate it. If you cross multiply, look at what you're going to get. This 1 minus du, 1 minus u rather, will cross multiply to this du part. And that will be 1 minus u times du. I'm separating already. and then dx times minus 1 will give us minus dx. So you can see that this is already a separated, separable variable equation. That's why I told you that this is already a separable variable equation, and at this point we can now integrate. To integrate this part, we open up the brackets. Is that okay? That will be integral 1 du, which will give us integral du, and it will welcome back the variable u. Then this will be minus u times du, then the integral. That is integral minus u du. Of course, we are going to get minus integral u du. And this follows power rule integration format, where you add 1 to the power and divide by the power. Because this u is a polynomial term, u raised to power 1. Add 1 to the power, then you're going to get minus u squared, divide by that 2. And the rate will be equal to, bring out the negative sign, you have integral dx, which gives you what? X plus c. We can now replace the value of u with equation 1, what u means. Therefore, here we're going to have, for this u, 1 minus x minus y, then minus this u squared, still 1 minus x minus y, all squared, divided by what? 2. Everything equal to minus x plus c. So this is the first hand solution to this differential equation. We are going to take a break. When we get back, we will now simplify this solution further to see another form we can get the result. You're welcome from the break. We obtained this as the general solution to this differential equation before the break. We now wish to simplify this equation or solution further. Is that okay? Now this general solution is in fraction form. It has the fractions. We're going to clear the fraction by multiplying the terms in the numerator through by the LCM, which is 2. Doing that 2 times this one will give us 2. 2 times minus x is minus 2x. 2 times minus y will give us minus 2y. Coming to this term, you have your minus, open your bracket. If this 2 multiplies this bracket, it will cancel itself. Is that okay as a denominator? So you still have minus, okay, you still have 1 minus x minus y all squared. Then equal to 2 times minus x will give us minus 2x plus 2 times c is 2c. Constant of integration, which will still give you what? Your constant c. Good. We are going to expand this bracket now. To expand it, you can do something like this. Is that okay? I'm going to expand mine, taking note that this minus x minus y can still be written as 1 minus open bracket x plus y. You can write it this way, then everything squared. Okay, so I'm going to use this format to really quickly expand it, but you can expand it using this. Alright? Let's go. So this will give us 2 minus 2x minus 2y. Then minus, come to this term. Expand it using this. I'm going to get 1 minus 2x minus 2y. Then plus x squared plus y squared plus 2xy. Good. I'm done expanding that. That will be equal to minus 2x plus c. This will also give us 2 minus 2x minus 2y. Open this bracket with this negative sign. You have minus 1 plus 2x plus 2y minus x squared minus y squared minus 2xy. Everything equal to minus 2x plus c. Good. You notice that this minus 2y will cancel this plus 2y. Then this minus 2x will cancel this plus 2x. We will be left with 2 minus 1 here, which will give us 1. 2 minus 1 is 1. We are left with minus x squared minus y squared minus 2xy equal to minus 2x plus c. Now if I collect this 2x to this left hand side and then multiply everything by negative, is that okay? Let's multiply everything by minus and then transfer this 2x to the left hand side. If you multiply this by minus, this one will change to minus 1. This minus x squared will change to x squared. Minus y squared will change to plus y squared. Minus 2xy will change to plus 2xy. Remember that this minus 2x is coming over to the left. So if you multiply it again by minus, it's going to change to minus 2x. Or as it is on the right hand side, multiply by minus 1, you get plus 2x, then transfer it to the left. Remember that you have minus 1 here already. Everything will be equal to c. And this becomes the simplified form of this general solution. And hence, the solution to this differential equation.